Problem 3. The manager of a company planned to distribute a $50 bonus to each employee from the company fund, but the fund contained $5 less than what was needed. So instead, the manager gave each employee a $45 bonus and kept the remaining $95 in the company fund. What was the amount of money in the company fund before any bonuses were paid? Alrighty, well, this looks like a job for algebra to me. I think what we need to do is convert these statements into equations. So let me define a couple of variables. So x, I'm going to call the number of employees. Number of employees. Alright. And let's call y the money in the fund. Okay, that's actually what we're trying to find. We're trying to find the money in the fund before the bonuses were paid. So y, what I'm going to call y, is the money in the fund. Money in fund before bonuses, right? Okay, so then we have a couple of variables to find, and then now we can convert these statements into equations. So, if we were going to pay each employee $50, we would take $50 times the number of employees, and that would tell us how much we would have to pay out. So let's do that. Let's take 50. Now we don't know the number of employees, but if we knew it, we would take it times x. We would take it times that number, and x is the number we're using to stand in place of the number of employees. Okay, and that would give us the dollar amount that we would like to have in the fund, right? If, we would need to have this amount of money in the fund in order to pay out $50 to every employee. But the problem says that the fund is $5 short to be able to do that. Okay, so we've got some amount of money in the fund, and if we had $5 more, we'd be able to do it. Okay, so that's just another way of saying that the fund plus $5 would allow us to pay $50 to every employee. Okay, but the fund's $5 short. Okay, so this is accounting for the $5 that we're short. Okay, so that's our first equation. All right, and then the second equation, let's convert this second sentence into an equation. Instead, the manager gave each employee a $45 bonus and kept the remaining $95. Okay, so now we're paying everybody $45. So 45 times x, which is the number of employees, that gives us how much was paid out to all the employees. Okay, and we need some money to be able to do that. So we have some money in the fund, and what we have left over is $95. So I guess that what this is saying is that if we could have $95 less in the fund, and still be able to pay $45. I could have written it this way. I could have said that if we have some amount of money in the fund, and we subtract the amount of money we pay for bonuses, and what we have left in the first case is a -5, right? We would be 5 in the hole. We would be 5 overdrawn. Okay. Now oops, this should be a 50, shouldn't it? $50. Okay. So these two equations are essentially the same thing. Okay. You see how I got that? If I were to subtract 50 from both sides and subtract 5 from both sides, kind of switch things around, I would get this. But this is just another way of thinking of it. If we were to pay out $50 to each employee, we would be $5 overdrawn in the fund. Okay. And the same way with this, we could do something similar. So we have $y in the fund, and we subtract the amount that we paid to the employees, which is 45 times the number of employees, and we're given that we have $95 left over in the fund. Okay, so we're not overdrawn. All right. So those are just two different ways of thinking about, converting these statements into equations. Okay, and it really doesn't matter which set we use. But actually, now that I see it, this one I think looks a little easier. So what would happen if I take these two? I've got a y here and a y here. What if I actually take the negative of this top one? Okay. So what I mean here is I'm going to subtract everything in the top from this bottom one. Okay. So then, so it's sort of like distributing, taking everything times minus 1, and it's distributing among the two. So minus y plus y is 0. And if I take minus 1 times minus 50x, this becomes a positive. So 50 minus 45, this becomes 5x. And again, when I take a negative of negative 5, I get a positive 5. So that's 100. Okay? And that's pretty easy now to solve for x, which is 20. Alright? And 20 is the number of employees. Now, it's always a good idea to go back once you think you've solved the problem and reread the question, because I don't know how many times it's happened to me that I think I've got the problem solved and then I forgot, oh yeah, that's right, I was solving for something else. So here we're solving for the amount of money in the fund before the bonuses were paid. So we're actually looking for y. We have x now though, so we can actually use that to figure out y, right? Because if we plug it into any of these equations up here, we can solve for y. Okay, so let's see. It looks like 50 times 20, right? And if I subtract, let's see, and then if I subtract that from y, which is the amount of money in the fund, we should get a negative 5, right? So let's just add 100 to both sides, and we get y is equal to, I'm going to add 100 here. So 50 times 20 is 100, but it's negative, so we add 100, that makes it 0. Let's add 100 over here. So negative 5 plus 100 is, yeah, actually, you know what? 50 times 20 is 1,000. Let me add another 0 here. Alright, so 50 times 20 is 1,000, right? 10 plus 2 more zeros, okay. Phew, boy, that's not good. Alright, so, alright, but you get the idea. So we have a negative 1,000, we add 1,000, we get 0, and we take 1,000 minus 5, we get 995. And that's what we're looking for, the amount of money in the fund before the bonuses are paid, which we defined as y. So y is $995.